Good? Okay, I think we're good. I think we can start. Maddie, you good? All right. Oh, no, still people coming in. Come on, mate, don't miss out, because I need to introduce myself. Yeah, that'll be good, MC. Thank you, thank you, thank you.
All right.
Thank you.
Welcome everyone to our talk.
I'll give you my mics.
Yep.
Go.
So I'll just give you a better background how I know this guy. 2000.
What is that?
And in 2014, at the time I was working for Cairns Marine, which I don't know if you guys know is one of the exporters out of Australia for coral and fish.
They're in here too.
They're in here.
Yeah, I'll put them.
I was invited by Jake Adams to talk at MACNA 2014 about Australian collection of coral and fish and sustainable. Ehsan was invited because he was bringing ICP to the industry, and it was the first opportunity for people to meet in America the guy who started the ICP testing for our hobby. So through the course of the few days we were at MACNA, Ehsan and I struck up a friendship. I was amazed, so I didn't know what an ICP machine was. And
yeah, he thought he's my friend, but it was pretty hard for me. It's a very hard time.
And I learned about ICP testing, and we became friends since then. So fortunately, after many years, 20 years working at Cairns Marine, I wanted to change. And after a couple of years out of the industry, Ehsan had moved his family and the company to Australia on the Reef, working on research, using our partnerships we have with the other collection companies, the coral collectors. You'll hear a bit about that in this talk. And yeah, it's been a bit of fun ride. So
yeah,
thanks,
it was
Ehsan.
for you. It was.
It was been fun.
It was for you. Yeah, yeah. It's very hard for a German to move to Australia. I'll tell you that. It's just hard.
It's a good place.
Yeah, it's a beautiful place, but yeah, it's difficult when you have friends like Julian. You know, it's too much partying. Too much partying. All right.
Thanks, man.
Okay. Thank you, Jules. Yeah, and thank you for all these possibilities that you give me. It's actually pretty crazy. I mean, Greg is not here, but all the guys that you know who I'm talking about. Thank you for inviting me here. It's the best show I've really had for years. I was not here in America for 6 years, right? So a bit of talks here in America on different MACNAs. In Brazil, I had a talk in. Normally we're all like very chemical, right? So it's very chemistry, and normally people kind of start falling asleep. That my absence in America caused, a lot of people to not know what we're doing, right? And not knowing why we're doing it. But really to understand where I'm coming from, what my roots are, right? And what Triton roots are. So let's just start with the origins. So that's me, my dad, my mom, and my wife. We started this company, Triton. In reality, I started this company because I was kind of a bit fed up, and I expected transparency, I expected innovation and knowledge from my hobby, from the vendors that actually, produce products for me and stuff, but I didn't find that, right? So that was 2008. I'm a reef keeper since I was 12, right? So, but I was not 12 2008. I'm now 25, doesn't matter. So just believe it. No, but I started a company with 25, right? So I started it, and I was talking to my dad, and what we realized is there is actually not much knowledge, right? And there is no drive for innovation. And we said, well, if we found a company, then it should be exactly that: innovation, drive, and especially creating knowledge, right? And a lot of people know us because we are the ones that said, we don't do water changes, right? And a lot of people think that's maybe a marketing thing, but it actually wasn't a problem with water changes. Is a misconception that you can reach specific things with it, okay? So you can reach stuff with it. It's a tool. It's a proper tool, but it's kind of an abused tool by marketing, right? And over marketing was what really, because I'm running an international company, but it's kind of, a bit of a, I'm a bit, cross with it, like I say. But anyway, water changes, we made clear that they don't. Why do you do water changes? You would tell me either, yeah, because they replace my trace elements, or I get rid of waste. I can export phosphate and nitrate. Both is not correct. It won't work, right? And I don't or to prove you that. And we can talk about. The only problem is everybody believes it. So everybody thinks there is no problem. And when there is no problem, then there is no problem being stuck in this situation of we have a problem, but we don't know about it, so we ignore it, right? And this caused a lot of people actually not go the innovation path, right? So they just said, all right, trace elements is no issue. I do a water change. It's wrong, but the industry would say, well, we can't solve a problem that is not existing there, right? So I was pretty angry with water changes. It was not really belonging to anything, marketing-wise, but it was kind of a really science-inhibiting factor, right? Just to let you know, people don't see it that way, but it is. So let's all the water change stuff. Anyway, so you guys can hear me still in the back there, right? Yep, okay. Found out that water changes are not effective was how can I actually prove it, right? How much visibility can I get you guys to be able to see that your salt they don't contain 10 times the trace elements or something. So if you would do 10% water change, you would actually. Also for myself, I'm a scientific thinking person, I would like a proof, right? So what I did was go on the step of innovation, and I brought ICP testing to this industry. I actually brought beforehand HPLC to the industry, and I was the first person to measure fluoride, right? And I know you people maybe think about fluoride because that's the new religion, but we can talk about it later, It's fine, you can ask me, and I have some data for you too, So this talk is split in four parts, and I will just go through them. You will see them anyway, I'll come to this. But, this was kind of the driving factor. We did quite more things, like I've not put in any innovation here because it's just taken too long. But the main ones for you is kind of very important, okay? So when you now look at just ICP testing, the problem is I was the first one to do ICP testing on seawater aquariums. So what about all these elements, right? Realistically, I needed at least one what you would need and how much vanadium is needed. There was over marketing, there's a lot of things, but there was no knowledge, okay? So we needed to make up all these set points. Until now, all these set points, when you do ICP testing with some other companies that do it now too, are still a standard, right? You need to understand, you wouldn't do it just to use like 2 years up, don't make money, and then still Triton stuff, right? Still, everything is still the same. It will be a 1 microgram difference, right? So it's not. What we then did was combining all this stuff to one holistic method. I'm not going through this. This is the Triton method. It's just going to be hard for you. This is the whole talk if I go through it. But it is the only kind of a very scientific-based thing. You can ask me questions about it if you want. But it is also a framework for us to do more science. You'll find that you can't do this with just one aquarium. Okay, it's just not going to work. It's not like, oh, in my aquarium it does that. And then you look at all the 42 other trace elements and they need to be always perfect. And this is just the 10,000 of aquariums, right? But they need to all work as exactly the same way, right? Which is really like hard to do because all of you will do little things different or big things different, calcium reactors, bacteria, whatever. But people that run the Triton method, the full Triton method, they do everything nearly. Little changes, if you have live rock or you don't have live rock, are visible for us. And it's just one thing. So we can really take data out of it. There's still, that run the Triton method in that time as more real data you can extract, right? I know this is a little bit scientific. Just wait. It's just not going to work otherwise, okay? So let's have a look at the Triton method created. So we did no water changes, so we didn't have any problems with salt. Nowadays, pretty much every salt is pretty good, to be honest, because they can't afford it. With all these ICP machines around, you go out of business right away if you have bad salt. Just to let you know, okay? Because I get this question all the time. What is the best salt? Which is the worst salt? All the salts are pretty much the same by now, okay? So we still don't do water changes, only if we need them to. You have, a really, really high level of reef keeping. So that's my tank, right? It's a picture. I will show you more pictures. But this clam is 70-something kilo. I need to take time, okay? So that's the tank. That tank was 1 meter 80, 1 meter 80. What's that in foot? 6 foot, yeah, square. So you can see there is nearly no space left. You know, everything is grown over. It's pretty much all this coral in the tank nearly were this small when I put them in, right? So, you know, the back ones, they're mariculture from Indonesia. Some of them are from Australia, so it was a very mixed kind of tank. For sure, like you can see all the acropora. There's that thing is, I think, you know, around more than a foot, like, yeah, 40 centimeters. So every little thing there, it was a different time, right? There was no fragging that much and things. And, you know, the colors, that's like an iPhone 6 or something, right? So it's not, there's no filter on this thing, right? So it's just, in that time, we had acropora. And that light I developed on my own. And it was the first light to be proven LED to grow acropora, okay? And I proven it over this tank. And I sold the light, and it was called the Lani light. That was my daughter's name. 18 and drives car, so I feel really old, right? But this is the truth. Yeah, that's the way it works. So there's other things. You can see all the corals grown up to the top. They actually built little islands, so I need to chop them off very often. So out of this aquarium, this is Joe. Some people might know Joe, you know, and Joe in the past got always a shower. So see the clam? That's what happened every day at 5 o'clock. So you could go there, stand in front of the tank and get wet. People did that. It was a tourism thing, right? This tank is in Germany, okay? So Joe came all the way to get a shower. All the way. He never showered before though. Don't go too close to him. So, yeah, there was Joe. So just to let you know how big the clam was actually, and that was still growing in that tank. Yeah, but we chopped out of this aquarium in that years. I think it was more than 7 years standing there. But we chopped out 145 kilo dry mass of coral. So that was what grew to everywhere. Just gave it away because they were grown like crazy. And that's because it's a real reef. It is a piece of the reef. That was my goal, right? It's like somebody went in there with a laser and cut out of the piece of the reef and put it in the aquarium. That was my goal, right? I really like that. Okay, so I'm not the type of person that would buy at worldwide corals. I love worldwide corals, but I don't know. It's just, this is not my type of reef keeping, right? And that caused us to do actually water changes. So it's a bit, you know, on my screen it looks better. But the white stuff that you see, they're eggs of that big clam, right? So that big clam spawned twice in that aquarium. And you'll see it in a second. And it just pumps out all the stuff. And then the little ones will go too, right? You see all the little eggs? The little ones will go too. So all this hormones and stuff causes the little ones to just go the same time, right? Very natural. Okay, it's absolutely crazy. I had things in that aquarium where it was absolutely crazy. And you don't need to freak out if you have a Triton method tank and this will happen to you. You shut down all the pumps and wait and everything goes up to the surface and you just take the surface out. Even then, it's not a big water change. It's just a little water change. It's not good for your tank when this happens, but it's actually a good sign, right? So anyway, this is kind of, you know, where we're coming from. Realistically, we quite changed the world of reef keeping, you know. Without Triton and without what my dad and me and everybody in Triton would have been doing back then, we wouldn't be here. And everybody that is doing an ICP test today is doing Triton. You know, so what we developed back then changed reef keeping forever. And worldwide we have, like in Europe, we have already 14 ICP machines operational, right? So not us, a lot of other people doing it now. So just to let you know, it's kind of a movement from the start, right? It's so long ago, some of you might think, you know, that was, ICP testing was always there. It wasn't, right? So we did this once, but because we wanted more. You know, everybody, the only question is, oh, what's coming next? What's the next big thing, you know? And that's real because, you know, as a company or as a person, you kind of want to develop a bit. You want evolution all the time, you know? And I wanted the same thing, right? So, and when I was sitting there and thinking about it, how can I go on? You know, back then, I was measuring all coral farms, you know? Everybody was working. Joe Waiula was sending me test kits from America. I was measuring all Japan's aquariums. Everything was measured by us, right? And really, in Europe, every kind of little coral farm was testing water with us. And we have all this data, right? I still have it. And I will show you. Not all of it, but some of it. But the thing is, there was actually, we're still doing it. It's a good set of data, but I wanted the next step. And that was when I was in Australia and had a talk in Australia. They approached me and said, oh, maybe we need somebody like you in this country. And it's very hard to get into, Australia is very hard with immigration and stuff, and migration. So they made it happen. So I went to Australia. It was very difficult, but why I did it will come up now. So it's a very important thing for you to understand too. So the present day is I live in Australia, right? So for 6 years now I live there. And, there is a reason for that, because people nowadays, when you go to a place like Worldwide Corals, or maybe, I've not been to Top Shelf, but it's maybe similar, where people kind of cut corals and sell them, you might think, that's it. There is no science needed anymore. These guys know how to do it. They cut them, and then reproduce them. They graft them, they stick them together and force them to live with each other, But that's not the truth, okay? It's not ending somewhere, it's really, we are still at the beginning, okay? And what you do and understand pretty quickly is that you need to reproduce where corals come from. So each coral that is living there, right, needs a habitat, a place that, genetically would match it, okay? Something that it knows to grow. You won't be able to, how long you graft them, you can't get a Montipora not, grown without calcium. It's not going to work, right? Or no light. Or no water. This is not going to happen, right? So you need, and we do that all the time. So when you look at your calcium measurement, for example, why is it 420? Why is it 420 or 440? Because somebody went and looked it up in the ocean. Where's 420, right? So do we stick to this? Magnesium, the same. All these parameters, they're all from that environment where the coral actually grows, right? So you need to adapt to this, but understand that not all of these corals grow at the same spot. So it's not the ocean. Like if you, where's the coral come from? Yeah, from the ocean. That's very generic, okay? So realistically, there is a lot of habitats. Reef, there is the reef itself, but there is the inter-reefal zone, which is mud, and all of these spots will have corals, different corals, right? So your LPS will be in the mud, some of them. Some of the SPS will be even in the muddy places, You need to really understand the coral itself, and then you understand how to recreate that place, right? What a lot of people don't know, that's maybe known, all these microhabitats or habitats will also have fluctuations. So when we have rainy season, right, sometimes the water just turns green. And I'm not telling you, it's not little, it's not like just, it's going out 70 kilometers and everything is green. So I'm running with the boat with Jules and we're going through green water all the time until it's dropping to 500 meters. And still there it was green. 500 meters deep water, right? So it's really crazy. And that happens just sometimes in a year because it rains a lot, And sometimes you'll have coral spawning. Then everything is covered in little eggs, or even the macroalgae will spawn, So it changes. So you can't just go there and say, okay, I'll take this water sample now, and I've sampled that spot, and I know everything about it, because it will change. And the coral won't go anywhere. They sit there, and everything changes around them yearly, maybe seasonal. They can't run away. So everything that kind of works out for them there, it might be in 3 months' time, they get all the nutrients they need. And then the rest of the year, they don't get any nutrients, and just live from whatever sunlight and things, and it's fine. But that's the habitat too. You need to understand that stuff too. Otherwise, you won't be able to keep some corals in the aquarium. That's why we can keep them pretty well, but it's getting better and better, right? So that's kind of the next big thing, to be honest. It's that knowledge that you need to build. And that's why I was there. That's why I took all that suffering and get my 4 kids to Australia, while 2 of them wouldn't even speak English. There was a lot of computer games for me. Massive amount of computer games, right? So What's also very important for you to know when I'm going to a place like Worldwide Corals, I'm sorry that I'm always relating to Worldwide Corals, but you know, you guys are from here, right? So it's just a bit, you know, it's a kind of your place, but well, you know, these corals are hardened. I hear that you know, they're not kind of, you know, they're aquarium corals, right? But that's not true. That's absolutely not true. So a little example for that would be, you think that's your coral, right? A pet, right? A very funny pet. Good, right? This is what you think is a coral, right? But what I know is a coral is that. It's a wild animal, okay? It won't kill you, but it's not the dog, right? So the reality is, genetically, all these corals we have, even if they have 20 years in an aquarium, they're still wild animals. They're still genetically exactly the same they were when they were collected from somebody like Julian. Maybe even Julian collected them. First place, same habitat. And we don't know that habitat. So realistically, what we do right now is even recreation before. And nobody else is doing that worldwide, you know. So it's the only ones, you know, doing this work. We are the only ones, right? And I told you also why, because it's quite costly, okay? So I'll show you a bit of our operations. So what we did was we have, you know, ICB labs everywhere in the world, like in Brazil and, you know, in Australia for sure, and in the UK. We have them, you know, in Europe, in Germany. And they're kind of the ICP labs you would use, you know. But we have an ICP lab also in Australia at the Great Barrier Reef. So that's me and Julian for sure. Julian looks really tall on this picture. Wait, so I just realized that next time I'll turn it a bit. But and what we also have is a boat in Australia. We have a vessel, a research vessel, that's Caliste. Caliste is actually the daughter of Triton, just to let you know. Okay, so that's why we choose that name. But a lot of people would think, why? Why do you need a boat, right? Sample and come back, right? But that's not reality, okay? So I want to just show you, make you understand how big the Great Barrier Reef really is. What's that? 22, what is that in square feet? 6 square foot? Really small areas that we need to look at, right? But that's our boat. Our boat is 12 meters long, so 32 foot. And you can see it going there. So that's our boat. We're just moving out. That's the reef we work at quite often, right? So with 12 meters, and that's the reef, okay? Wait, that's the smallest reef around, okay? That is not the biggest reef. You see that thing? Okay, it takes me 10 minutes to go around it, and I can go 40 knots with that boat, right? So it's really big, but it is the smallest reef around, right? So see that little mark? That small red mark there in the middle? That's the reef I showed you right now. Okay, that here. Here. That red. Can you see that red mark? I don't even know. It's really little, right? This thing is a monster, right? It's like, I'll use half of my fuel to just run it one time up. That's it. Like really, it's so long, right? And this is just the ones around Cairns, okay? So we work on a lot of reefs out here. This is all reefs, right? This is already like 50 times the size of that little Barrier Reef is though. That's the Great Barrier Reef, right? And this is Cairns. And I still have marked that red little thing. You might not see it though. That's 2,000 kilometers of reef, okay? So if you understand that, you understand why we need a boat. Because it's not like just sampling one spot and find the next spot and the next spot. We're going around looking for it. It's taken ages. We are hours on our motors, right? So that's a long, long way. It's actually nearly 2,000 kilometers. It's nearly a whole reef we would have, you know. Moses, I'm doing sampling. So I'll just show you one because we have like a little drone, like a little underwater drone where we do the sampling with. We have a little, it's sea view, it's like a little holder for a camera that you drag behind us so we find the spots, you know, like we have a lot of little things in, so we don't, you know, we need to do things fast, right? But we still do sampling on other stuff too. It's not only water, right? So I'll show you this video. So in how much poo it is. Please look at it. It's unbelievable. I was swimming through poo, right? This is a spot that we call the toilet, right? Because there is so much parrotfish around, right? But this stuff is super important. The big parts fall down quickly, right? While the other parts, they go in. This part size is really good for your corals, right? And then I have my wife collect fish poo days ago. You know, she's really good at it. I can't do it that well, you know. That's a slow-mo. She's faster than that normally. So really, realistically, you know, we can't get that stuff right now in that little bit. We have other things we use. Coral food, you know, because we're out of this, you know. We do our science and then we go further, and we also do external work. So that's Cairns Marine, that's where Julian worked before. They have bigger stuff, you know. They bring us samples from the sites where they collect. We do testing every week in their facility. You know, that's like big things. They catch big sharks. It's just impressive, right? They are the biggest exporter around. So it's a really crazy company, but a lot of stuff we learn from them too. You know, so as soon as you're in that hotspot, in this boiling coral, you know, fish hotspot, you can learn a lot of things, right? And through everything. And I want you to ask questions, right? Because that's very important for you guys. But let me tell you a little bit, and I'm not sure which way that goes, what we kind of really do actually to make products out of it. I'll jump over that because that's a bit like QC stuff. But let's talk about this, right? So, you know, I'll tell you all the stuff that I've data, I'm testing your water, all this, you know, framework things. But let's have a look at some of the elements over the years, okay? So this is all the tests done in America, right? From 2016, only base red one is showing you how nearly all time you will have phosphate in the tank. There is no tank in America will come up with zero phosphate. I'll tell you that. That's very, very rare. The only difference is you can see a difference here, right? That's when people test fresh water. Then it comes out zero phosphate, and it will be coming into this thing. But we can extract that too. It just didn't do that here. So I run data crunching on it. But what you can see here is, look at 2017, right? What's that? So this is the median of how much phosphate was in every test we have. Americans went full on phosphate. Like, I know, there was, you know. And we're looking at the things because often these things have to do with something that somebody told you somewhere. Like, let's say in the internet. Okay, and there is a guy and says, oh no, we really need phosphate. And I think if I go back, I'll find, you know, somebody that was important saying, oh, phosphate is important, so put it in. And that's what you see. Look at 2017. Didn't work out, right? It was wrong. That's why we went back, right? But just to let you know, okay, and when you go back, look at Magnus, look at all this information, this marketing information causes that, right? But the reality is people want low phosphate, okay? Just to let you know, like you can extract a lot of different information. I would just need to go out for a second. So that's barium. Go in again. So let's have a look at barium. That's interesting too. So barium, tested total, always in, exactly like phosphate. So it's very rare that people in America would have no barium. Look how often we found 2023 barium in your water. Same thing, right? Somebody might have told you or start selling barium, and then all of a sudden people got barium. But next year, went back again, right? So again, like this, we'll just, you know, do them and find, we'll find out, just not going, manganese, my sampling here. Not often, but the red one means we have found it. We don't find manganese all the time, we don't find it, we find it. So just to let you know, it's like important for you to understand that. And we're very open with this data, right? We don't give you amounts and stuff often because that's kind of our IP. But we will tell you what kind of is important for you and what's not. There's fluoride. Can you see the fluoride? Wait for it. It's good. It's coming. It's coming. But iodine is not bad too. Iodine is good too. So let's have a look at the iodine. Wait a sec. Yeah, here you go. So, same thing. Iodine, 23 still dose less iodine, right? But iodine is a good thing. So when you look in the last 5 years, people started in America to dose iodine and then kept doing it, really. See what I mean? Like it's, when you look at here, total tests where it's detected, okay, but here, you know. So the same thing is when you look at, again, that will be a communication thing. Somebody would have said, oh, iodine is super important, and a lot of people started doing it. Type of detection, okay? This is fluoride. Cut it to the last 2 years because we're not doing, we started fluoride again. You know that? Or maybe not. Okay, so I was the first person to measure fluoride, okay? And then I said, it's not worth it. It's not beneficial for anything, okay? So I left it. I went away from it. But other people made it a religion this later, but I still don't think it's important, right? If you look at the data, the amount is more important here. We actually find quite a lot of fluoride anyway, you know? So we measure it, everybody has it, and we find quite a bit of it, you know? It's not like you're depleted. Nobody is depleted. And when you understand the coral, available. Biologically, that's very often the case, okay? So it's not like if something is 4 or 3.9, it's making a difference. No difference, right? It's available. If it's 0, it's not there, that's a problem, right? But you can see that's not the case, right? Just have that in your mind. If you want more of these, come to the booth and I will tell you about it, right? But we do that every day. We do that all the time, you know. We do that even with like other tests, you know. I have NDoc tests. Sorry, I should have brought that for you. I'm sorry, Salem. Sorry. Okay. Next time I'll bring you the organic carbon. That was interesting too, actually. I'll show you at the booth. Okay. So organic carbon would be something, you know, NDoc. But we have done so much stuff, and this will be taking so long if I go through everything. I'll just show you what the poo does. Okay, so that's the product that we made out of the poo. Dropped it on a coral, right? That's obviously the speed that Australian corals normally act. They're very fast. That's time-lapse, okay? But you can see the coral start eating it, and you can see it sucking it in. You will see it right now, and it closes it off. So it sucks it in. And you can, that product, for example, will reduce your waste in a tank 70%, right? So you just need that stuff as a carrier. It's a carrier. It's not having any nutrient in it, right? It's just a carrier. Like, you know, the fish would eat something like algae and will kind of metabolize it. And when they poo, they bring out some nutrients and stuff with it. This is what we thought, and that was the theory. And we found out that works pretty well, you know? See how it eats it? That's pretty good for the corals you buy here. That's all LPS for sure, but right? It's kind of this same biological, like we reproduced it. Now we put it on, it's just opening them up right away. They just love it, right? This is the way it works, and that's how we translate our knowledge at the end really into a product. And we do that all the time, right? And I think this is really the most important thing to kind of give you today from the perspective what we do and why we do it. And a lot of people here would maybe understand now why I get a boat and I go fishing with it, for sure. But I do other stuff with it too, right? So that's really, really important up here. If you have any questions to anything, even ICP-MS, the religion of fluoride, organic carbon, Salem, if you have any questions, just let me know, okay? It's all good. I have enough time. I think we can run a long Q&A if you want. But give me your questions now, okay? Thanks a lot for listening. Yeah. Wait. Never showering. And you're working. I wasn't joking. It's good. So any questions, guys? Anybody online can ask questions too, right? So, yeah, Julian will do it. Julian turned on that thing. So if anybody has any realistic question to this talk or to anything else, let me know. Jules, anybody online? Yeah, because there was no difference.
There was no difference?
No. So I started testing it 2008, And I tested it with the HPLC, so it's another machine, it's not an ICP. So just to let you know, ICP cannot measure fluoride. So forget about it. It's always another machine, right? And it's had a total different precision and accuracy, so it's just to let you know, this is misconception too. And I tested it on my tank, I tested it on all the aquariums that we kind of have at Triton, the Triton systems, and just nothing happened. So the realistic was that as soon as somebody started copying the ICP stuff from us, they needed a point of differentiation. So, and that point was fluoride. So you give somebody fluoride, he will possibly come to you because we're not doing it anymore. That is, I think, why fluoride came up and then was hyped so much. And then at one point we started fluoride again because the people wanted it, you know, it was enough. So then we started it again. We use it though because I realized in places that are very warm, like here, you have it sometimes in your fresh water. Like they put it, you know, fluoride or chloride, they put it into the, but it's coming out of the tap, so it's clean, right? And that's a problem for some people, you know. But realistically, for dosing, I will not dose. I will never dose it in my tank. You saw it, and I never will dose it. I think in my new tank too. Maybe I try it again, but I don't see any benefit.
A question from Austin Barnhill, 33. How old was the large clam?
Around 12 years, I would say. I got it from an aquarium that where it's gone to because it's this little and they didn't know which that's a Geiges. So I got it there, and I don't know how old it was before, but I would say around 12 years, realistic. Oh, you had a question.
You've tested tanks from all over the world. You live in a couple countries. Any interesting trends with tanks from all over the world? Like, do you see something with UK tanks versus Australian tanks versus American tanks?
Yes. Yes, so you know, I'm doing it, so half of this talk, the inside part, right? That's a talk on its own. So what I did once was I gave a talk where I actually split up every machine and talked about every single difference in these countries, right? And it is really interesting because you guys here, I'll talk just about America right now, right? But for example, Brazilians are so tight with silicates. They have the lowest silicates amount from all tests in the world. Like, it's unbelievable, you know? So they go really low. Like sometimes I come up with 22 or something. It's so low, right? Nobody else has that, right? Or so what you can see is, you know, that information flow. You can see that too. So the UK, I'm sorry UK, but they're super messy. Like they have all problems, you know? So it's because, you know, they're so close to Europe, right? But they also listen to the American kind of voice, you know? So they have both sides. So what happens in Europe, like the phosphate thing, I guess they have two spikes, you know? Like one coming from Europe, the other one maybe coming from America in different times, you know? So it's really interesting. It's really cool. Australia are pretty good because they're using natural seawater. That's cool too. So they are really, I don't know, maybe because they keep a lot of fish or something, you know. But Australia is different because Australia is only like 28 million people, right? Compared to America, that's a totally different thing. Here you go.
So I assume you've analyzed the parrotfish waste, and if so, approximately what percent of that is dissolved organic compounds versus calcium carbonate?
I won't like to answer you that because, you know, I'm living from this information. But it is quite a bit of calcium carbonate still, you know. What we do is we collect it in different ways. So if you collect the water that is around it, if you fast enough, like if I let my wife swim really fast and get it right away, then you get a little different composition. Right now what we're looking at is the composition between the species different. That's a very important thing too, you know. It might lead to, you look at a spot and see a lot of parrotfish that are one species, and that reef is maybe more healthy than the other, or another coral is grown more specifically there than in another spot. You know what I mean? So you know that biologically that's quite important, that you have a grazer, you know, something that, you know, when you have like really big fields of grass, they will suffer if there is not a horse eating it, or, you know, like there's a proof for that biologically. And a similar thing we assume, and we don't know yet, but assume that is happening in the reef too, you know. So even if they graze and hit and scratch the coral or kill the coral, it might be something that needs to be done in that environment, you know. So we're kind of focusing right now on that a little bit. We have the carrier, and then we try to maybe find what is really, organic stuff is very hard to analyze, you know, so it's very much harder than like, you know, we'll try to analyze it and see what really compounds they might eat, you know. But right now it's more like, the habitat thing is a bit more interesting and easier to get. Like, so Julian always says it's the low-hanging fruit. You know, like we go for the low-hanging, so you gain the most out of the low-hanging fruit, and then we keep going up.
Just explain that that product you infuse, it's not actually, as Ehsan said, carrying anything itself. It's more about delivering whatever you're trying to get into your corals. Like if you're doing aminos or you do nitrogen, ammonia dosing, then you actually infuse that inside and puts it into effectively replicating the matter, the particulate matter of the
Yeah.
fish. That's
So-
it's a carrier.
So why we're doing it is, look, you buy a coral out here, right? And you need to feed it. And while you're feeding it, and to make it look nice, whatever, then you will create waste, especially when you use a liquid. You use a liquid, how much is gone into that coral? You know, it's all in your water column, right? So when we try to reduce that waste, so you can target feed them with whatever liquid you want, but you solidify that liquid, put it in the coral. That's causing you 70% less weight. That means you can keep 3 times more coral. You know? Like feed them the same amounts. Or you can feed that coral 3 times more. Get the same amount. That's kind of the goal of it. That our products are very much always something that we try to create something new. You know? We do not really want to create a coral food right now, because there is some coral foods out there, they work, you know? Like the same counts for GFO. We don't have GFO because we don't need GFO. There is GFO. You buy it from Julian Sprung, from the other Julian, you know? So, you know what I mean? Like it's not, when there is no need for something, then you don't do it. But as soon as we try to detect these issues, like the water change, it was an issue, right? So we detected it, then you solve it, and then you get something really good. That's what we do. That's how we think, you know?
Right, I've got some questions.
Yes.
Reef Sand says it's very difficult for him or her,
Yeah.
to keep Acropora alongside trackies and acans. Any advice?
Very normal thing. Mixed reef, super mixed reef. Like trackies living in the mud, Acropora living on top of the reef normally, like the most of them. And what was it? What was
Acros against trackies
and I can understand some of them very cold, right? So low and cold. So yeah, it's normal. So you can only this is why we're doing this, right? We know about it. So what you need to find out in this case is what's important for which coral, right? So if the cold water is important for the one coral, you have an issue because the other ones don't like cold water. But if it's just something chemical or food, you can solve it, right? So I guess, Acropora, she's a bit...
So when you're trying to keep acro, which you're trying to keep low nutrient, crystal clear water where they live.
Yeah.
And then you want to keep a trachea and an acan, which lives in turbid water, with a lot of, you can feed them a lot.
Yeah, you have choices with Acropora. Acropora is very common, right? It's a very robust, but resilient coral, right? Growing really fast. Montipora too. So you could choose maybe a coral a Montipora, Acropora that is easier to keep. So way more to the side of the inner shore. But you need to know which coral that is. That's kind of the next thing. While something like strawberry shortcake, thank you for that name, Joe. It's an awesome name, strawberry shortcake. I don't know. So it's fine. And Clados, that coral, that real strawberry shortcake thing, is growing like and normally at a place where you have upwelling. So it's like really deep and comes up, and they're like sitting there.
One of the biggest current problems in marine aquariums.
It was. The data prove prove that, you know, it was. It is still a little bit because of products that promise you one bottle solutions, right? So organic carbon for alkalinity is a problem right now, in my opinion, is a big problem right now. And it's not leading to like using organic carbon to raise your alkalinity, and it lowers your nutrient. That's what happens, okay? But so when your tank grows bigger and you want more alkalinity, you need to raise more alkalinity, you lower the nutrient more. And at one point there is just too less nutrient. So it's not a one bottle solution. You need to then add nutrient, which is 2 bottles. So you end up with 3 bottles again. You know, so it's only short term. You can do that, but at one point there will be too many bacteria needed to kind of transform that organic carbon into that carbon that you need, alkalinity. And I see a big problem with that. So for my aquarium, you saw, I had a drop of 4 DKH a day, every day. I mean, that clam was massive. The corals were all 1 meter big. It wouldn't work with organic for a while, and then you get your problems.
Okay, another one from Rachel in Brazil. Will we face more and more difficulties to treat RO water?
And like,
will it impact ICP?
He means that
the increase.
The water that the government kind of too much, because you know when you look at Europe, like the UK or Germany, they have really bad water, like they have, you know, like hey, it's a case. I mean, I'm not drinking that water, man. But sorry, you know, but in America and a lot of places they have good water. I talked to Josh from Worldwide Corals. They have an issue with water here, like here in Orlando. You know, they have because of the spot they are at. You know, so it really depends. I wouldn't say it's a bigger problem than it was before.
Okay. Canal Reef Tech, Jeffy.
Oh, Jeffy, salve.
In Brazil,
yes.
Why all-in-one solution need to use organic carbon to generate DKH?
What's that question? Like, why? Why is that? Yeah. Because you need bacteria, eat it up. Very, very simply said, you need a source of carbon to get the inorganic carbon, the alkalinity out of it. And that source is the organic carbon in that case. If you can use inorganic carbon directly, like bicarb, that's what they need. So you put it in, then you don't need to wait. It's right away available, and that's the way to go for me. Anybody here?
Any other questions?
Come on, UK. What's that? Yeah. I'm not coming to you for the next 6 years, so I'm here now. Just to insult you. Yes.
I was just wondering whether he's been asking if you can do it with humans.
Not this morning.
All right.
Just wondering whether you think that you will end up going down a route of more information regarding fish nutrition in terms of what we're feeding our fish. If from the video we sit there with the corals consuming what you put into your tank.
Yes, we will do that. With the new tank, we'll try a little bit too. So that we are at the source very much too. So we can even use live food, you know, from the ocean. That's pretty good because I can just go out with it's going to be hard, but it's still working. Like with the plankton net, we have a lot of antias in there. It's very difficult to do, you know. So we need a whole protocol for a lot of things to exclude errors. That's really hard, you know. So I will try at one point. It's not a low-hanging fruit, right? So I don't expect it to be very important for you as reef keepers. I will be interested in it, but I don't expect it. What would be interesting for me is and then, you know, so don't get that much waste and stuff. That's interesting for you guys and interesting for me too because I have antias too. I love antias, right? So that will be something I'm looking at, but it's maybe not like, you know, you analyze exact dots.
Arundus?
Yep.
My corals really like your Enfuse. Is it possible to add vitamin C or other vitamins to help boost uptake?
Yeah, you can just add Enfuse. You can do whatever liquid you want in. You can do, yeah, you could do that. But No, don't overdo it. Like vitamin C is not, like, it's also not good to have it too much. You know, just it's it's organic carbon too. You know, so be careful with it. Any question here? Here you go. Yeah, I will do that at the booth when you come.
Oh, okay.
Yep.
But maybe just just at a very high level, if you could just explain in fewer no water changes or that, just at a high level.
Yeah, very simple. I can do that too. Okay. So you need to imagine a water change for exporting nutrients. You do 10% a week. Okay. So if you would just do that, we would possibly all agree it's not enough. Okay. Without a filter. So you also have always a filter. You know, you have always a filter that extracts to it. They're doing the filter. Okay? So 90% to 10, you could to get my filter 10% better. Then I have 100% on the filter, and I don't need my water change for that reason anymore. Right? So this is the way we filter more efficient, which we did in a very simple way. Like we have an algae bed that we deliver. We support it, like we supplement it. And that's making the filter way more efficient, which then causes us not that you need to have in mind too. But this is a very simple explanation. It's very much what we do, you know. So it's very hard to replace, but it's not that effective. That's why it's easy to replace, you know. So that's the way it works, right?
I think that's a thing that is commonly misunderstood is that people think you put an algae bed or algae filter, reactor, scrubber in your aquarium and it's just going to live off what's the nutrient coming from your fish and your coral in the tank. It's actually adding to it, and that's part of the supplement management, is putting in and supercharging that algae bed to then remove the other nutrients you want to get out. So
yeah,
that's important to know.
And you need to also know that algae, just for not simple, but you know, algae or plants will live in different soil. You know, like some like the high pH, low pH, high K, low K, NP, whatever, right? And the same thing happens with your I think that's a coral. That's a coral. Here you go. So the same thing happens when you have your water and you change it. You something happens with it. You know, like let's say then you put in your antias and you feed them heavy. Then your water, your soil changes. Then you need to have another algae grown, right? So and it will adapt. So that's a very important thing to Triton method too. We leave it natural. So sometimes the algae changes. You know, it's not like always you keep on having Chitomorpha in there. You will possibly change it over to another type of algae, but you're not doing it. It will grow on its own. So we call it the dominant algae, right? And the dominant algae changes over time when you have the Triton, when you run in the Triton method.
That makes the light that you put over the refugium extremely important too. A lot of the lights you see on the market that are sold for refugiums are very specific wavelength. They're LED. They have kind of reddish colour.
Yeah.
They're only really good for growing some types of algae. So you really need to look at having a broad spectrum light over your refugium to allow the refugium to grow different types of algae when they're needed.
Yeah, we call that the limiting factor. So you have two limiting factors. One limiting factor is the light. The other limiting factor is what is needed, the micronutrients that are needed for each algae to grow. You're getting really good, you know, in that. That's why, like, need to use, you know.
I've got a couple more questions.
Yes.
Emerald 58.
So from New York. Here you go.
I'd like to know, for elements that are supposed to be undetectable, such as chromium and cobalt, should I be dosing small amounts and is it beneficial?
It could be. You need to ramp up your ICP test to detect any kind of chromium showing up. Normally chromium and cobalt, especially cobalt, is in your aquarium because it's in fish food, right? So it will, to that little amount that you might need, kind of be present. You know, whenever you feed your fish, you kind of have a little bit of waste. They will split up, and a little bit of that cobalt will be there. And chromium is very similar. They are too low. I'm not dosing them, but you can. It's not harmful, and you just ramp up a little bit your ICP.
If you do it properly, what should you? What
1 mil.
See different though with some coral.
You can't say that. So okay, that's the important one too. So the reality is, all these trace elements we sell, right? It might be you dose all of them, and no coral in your aquarium will affect show effect, like show anything, right? It might be that you dose only one because there's too many corals around, like in the world, okay? And you can't do that. You can't say this is for that coral, this is for that coral, okay?
Well,
so what?
This increases that color.
Yeah, exactly. You can't say. So what you do is specific functionality. So some of them are good for metabolism, we know that, and some of them are, so you can say that. And then you add them, and some of them might enhance your color. And maybe one of them, is your prime super coral. You love that coral, okay? That's for me something like. And then you go and add zinc, and then add me. So that yellow coral that is on our booth, that's my coral, right? And that yellow coral went crazy when I add zinc. It went super yellow, like Acropora, right? And so I kept dosing zinc, right? But then I kept dosing vanadium, and no coral in my tank really reacted on it. Only like there was like some sponges and stuff growing crazy. So slowly and add one after the other, and you might end up with like 4 bottles of trace elements, realistic. But I don't expect you to go all the trace elements. That will not happen. That's unrealistic, okay? Just to let you know, it's just got a misconception too, especially here in America, right? Like that you need everything all the time. That's not true, okay?
I've got another question from Emerald.
Yep.
He said, also in some ICP tests I've seen from various of my service accounts, I noticed lithium levels extremely high. How does this affect the health? And 2, what would be the best way to remedy?
Water change. Remedy is water change because it's too much. But lithium in America, actually my first talk in America, it was very visible that you guys have crazy amount of lithium. And it is because your magnesium, I found out when I did the first times I did testing on American water, and it was because there was to make your biopsies go away. I don't know if you remember, actually years ago, right? And this was magnesium, so magnesium does not make bread, right? Just because of contamination. And we realized that really works. So when you lift your lithium around 1,000, which 200 is the normal amount, so when you go up to 1,000, the biopsies, 50% all biopsies will start suffering, so you get rid of it, it's a good way. But on the other hand, like your polyps, they don't like it. They will close, They won't die, but they will close. Zoanthids, yeah. So it won't be really, it's not really bad though. It's not something you panic. You have it. We see it all the time in America. People, sodium, right? But it is not a trace for me. So just have that in mind. It's a very light element. So there is a lot of atoms of lithium around. It's like, a big bag of feathers, It's not heavy, but it's a lot, So it's the same with lithium. So don't overdo it. Just try to keep it down. I would do a water change.
What's a dangerous level in your mind?
No dangerous level. I've not detected any dangerous level yet.
So being that you said it's a magnesium impurity, and we're here in this case, there's some of the salts that might have that impurity, so we recommend, like I talked to you before, natural seawater instead, to bring that number down, because I noticed my lithium, I won't say a salt name, but I kept using that salt in my lithium, and my barium just kept going up, and I couldn't figure it out. And then
can you recommend natural seawater? Like, look, I'm a chemist. I can mix you really good salt, right? But I will never beat natural seawater. It's just it's not going to work, So when you can use it, use it. Be just careful, Send an ICP right next to it. You never know, I've seen everything.
What other things with natural seawater, what specifically would you look for as a problem?
I would take it deep. So I would always take it at least like 2 meters to 5 meters deep, right? That's good. That's a good idea because surface water is not or green. I'll send it ICP and just check it before you use it. That's a good one.
We often get asked, does it have to have UV sterilized?
And source water. So, check it chemically and leave it in the wherever, just leave it there. Everything will die in it anyway. And it's not too much in it anyway.
Everyone's got another question.
Yep.
He said he's asked this question before, but thought people might be interested to hear. In other methods, people are dosing rubidium. What do you think about that? Is it beneficial to any extent?
Yeah, I'll bring uranium next level. Just good because I'll make a lot of money, can buy another boat. That's for me rubidium, Like, honestly, there's so many elements on that periodic table. You can sell each of them. If I would stand here and tell you, oh, I have found the holy grail, rubidium, yeah, and then next year it's gone down again, because it's like barium. It's like barium. Same thing. There's companies selling barium. Realistically, you just add a little bit of dry food and you will have barium. Has been abused because, you know, it's great, you know, if you test something and then you sell something, you know, but it shouldn't be that way. You know, it's realistically not every element is beneficial, and mostly they're not. And if somebody comes up with something just because you want to sell it, he should just come up and say why, how he found out. You know, realistically, there's something that I'll give you here in America especially too. You know, nobody wakes up and has all this knowledge in his mind. Like, and you know everything? No, nobody does that, right? So you need to do some work. You know? We talked about it yesterday with somebody. He said, like, I could buy 5 ICP MS for it, or 5 more ICPs for it, right? Like, it's expensive. But in the effort, like, we stand up 4 o'clock in the morning to get out there and just put, you know, it's honestly, I could stand up, you know, and just say, I got it. That's it. Just sell barium, you know. But don't believe that stuff, okay? Just ask the question. Where do you know it from? Where is it? Just let me read something. Let me see when you found out. And if he says, oh, I just put it in my aquarium and all my corals get... Here you go.
The 2 most common questions I see that people are always asking, the single little bottles, and I put them in one thing and use a single dosing pump. So first is, can I do that with Triton? And then second is, why does Triton still use OES?
That's typical reef building. Yeah, you can do the 1 bottle solution with Triton. We do that a long time. We have a calculator. You can put your amounts in there, and then you can mix 1 solution. It took a while for us to create that, because it's not too safe if you just mix it like that. But if you do that the way the computer tells you, it's pretty much easy. And I think we have that a long time. You're using it, isn't it? Yeah. So you can then just use a dosing pump, and over a month or 2 months, you have that for a long time now, right? The MS question is... Yeah. So, okay, so that's because, you know, you need to look at... It's true. The MS, the machine MS, is more, not accurate, but more sensitive, right? So it can go lower than the OES, okay? That is the true thing of it. Where the misinformation comes from is you don't compare only machines here, right? You compare limiting factors, okay? Again, like limitations you compare. So what we have is seawater. Seawater is horrible to test, right? There's a lot of salt in there. You don't want that salt to get into any machine. For example, just an example, right? So the MS will measure the salt in the water. So the salt enters the machine. The OES will not do that. It will just measure light. That means that all the salt, to understand the main difference between the things. Now, if you look at that, you parts per quadrillion, right? So it's acceptable in that you can't still do it with an MS in your aquarium, because you need to have a guy that samples the water, thing that swims a little bit in your water, like 1,000 times less, contamination will show up. So you need to be 1,000 times cleaner than you are right now. And that's something that you can't do. So the limitation is the environment of the testing. So all the way from your home to the ICP-MS, that's the issue, right? The same with the OES, but we don't expect to go that low. So it's fine. And to kind of picture this is, a Ferrari, right, is a super fast car with a super good motor, right? Like, let's just agree on that. It's awesome fast. And a Jeep is not that fast, right? But if you want to drive this in a desert, you're not going with a Ferrari, right? It is a faster car. The MS is the more precise machine, like more sensitive machine, but not in the environment that we're doing. Not in the desert, right? Not in salt water. That's the reality of things. Yeah. So you don't achieve what you want with it. You can't drive it,
Save $25 and buy an OES? What is that like?
Sorry?
Save $25 and buy an OES?
Yeah, exactly. It's pretty much the same price. Like people would think an MS is more expensive. It's just not other technology. It's not that much more expensive. You know, so I could have bought all MS and not OS, no problem. But with an OES, you just put the sample in, done. 0.2% is the highest amount of salt they can measure. And we have already like 15 times. So that error in that liquid you diluted with, and then you want to go parts per quadrillion? My God, it's not going to work, you know? Because, you know, it's in wet, that 15 times more, you know? So, I don't know. Everybody can explain you how they do it without all these issues and, you know, how they can run their Ferrari in the desert. I'm good with that. Maybe ask in Dubai. Maybe they can do it. Yeah, they know. They might know. Anything else?
Thank you.
Thank you, guys. Thank you very much. Thank you. And thank you, everybody online. All right. Yeah. Well,
Thank you very much.
no worries, mate.
Thank you.
That's good. Thank you. I'll see you hopefully in California. I think I'm coming to this place again. There you go.
Awesome.
Good job, mate.
Awesome.
Good one. I'll just switch off the live. Say bye to them. Come here, Luis. Come here, Luis. Look, boys. Aquakilla. Aquakilla. See you. Thank you. Thank you.
Thank you.
You already know.